Hello, my name is Amanda Leigh Walters, and I'm a PhD student in the Horticulture Department at the University of Arkansas. Today, I'm going to be talking about how we calculate the amount of fertilizer to apply for established blackberries. Specifically, I will be focusing on nitrogen, as this is a nutrient many growers are also focusing on. Generally, the current recommended rate for the annual nitrogen application to blackberries grown in the southeast is 60 to 80 pounds of nitrogen per acre. But remember, you should still be taking leaf and soil tests to be checking that the recommended rates are sufficient for your specific plants. If you don't know about leaf tissue sampling, check out our other video on that topic. Keep in mind that for blackberries, nitrogen fertilizers should be nitrate-based. Blackberries are known to prefer nitrate-based fertilizers over other forms of nitrogen fertilizer. Most often, growers are recommended to either use calcium nitrate or potassium nitrate. The method you use to apply fertilizer will impact how much fertilizer you should put out. I will be discussing how those methods impact this later in the video, but for now, just know that there are two types of fertilizer application: drip irrigation or fertigation, and broadcast application. The size of the area you are fertilizing can be impacted by many things. You may have fields that are similar sizes but could actually be fairly different in total area. For this example, these fields look to be similar, but when we calculate the area of one field and the other, we see that one is much larger and would thus require to be fertilized differently. Here on the right, we see a bag of CaNO3. This is an abbreviation for calcium nitrate. In the box here, we see 1300. This is the nitrogen, phosphorus, and potassium content of the fertilizer. These numbers mean 13% of this bag of fertilizer is made up of nitrogen, while there is 0% P or K in the bag. Then added on is a plus 18 Ca. This means there's 18% calcium also in the bag. All fertilizers report the percent N, P, and K contained, but other elements may not be reported unless they have significant amounts in the bag. In all cases, you should check your fertilizer's guaranteed analysis, which should be printed somewhere on the bag or provided to you when you purchase fertilizer. If we want to apply a rate of 60 pounds of nitrogen per acre and the fertilizer is only 13% nitrogen, you're going to have to apply more than 60 pounds of this fertilizer, because essentially this is saying that for every 1 pound of fertilizer, we are only supplying 0.13 pounds of nitrogen. To do this, we would divide our recommended rate by our percent nitrogen in the fertilizer. This would look like 60 divided by 0.13 for this example, which would result in 461.5 pounds of this fertilizer being required to meet our planned rate of nitrogen. Also meaning for every acre of production, we need to apply 461.5 pounds of this specific fertilizer to get 60 pounds of nitrogen rate. Let's put a pin in the math for a moment and discuss how to apply fertilizer and how to determine the square footage of a production area, both of which impact the calculations for our required fertilizer rate. There are two popular methods of applying fertilizer for blackberries. Drip fertigation is when we inject fertilizer through our irrigation lines, seen here in our picture. We are often injecting these through some type of dosatron or venturi. The other option is broadcast, which can look different depending on the scale of the farm and the equipment being used, but is generally spreading fertilizer granules with a broadcaster pulled by a tractor. Let's take an example where a farmer is using drip irrigation and injecting fertilizer. Fertigation applies only to the row and does not account for the row middle. Thus, we only calculate the area of the row and exclude the row middle in our calculations. For this example, let's assume the farmer has 100 rows that are 100 feet long and 3 feet wide. We would multiply these three numbers to get our total area of production, which would be 30,000 square feet. Remember from earlier, we had that fertilizer rate that was 461.5 pounds per acre. There are 43,560 square feet in an acre, so to change that to feet, we would divide our field area by this number. This means we're probably actually going to have less than an acre under production in this example. So we'll go ahead and calculate that. and we'd see that 30,000 square feet divided by 43,560 is going to give us 0.688, or we'll round that up to 0.69 acres under production. So with our new area in acreage, we will multiply that by our rate, which is that 461.5 pounds of CaNO3 per acre, which would result in 318.44 pounds of CaNO3. Keep in mind that this is the total fertilizer needed to achieve 60 pounds per acre, so this is for the entire season. We recommend for drip irrigation to start in the spring at primocane emergence and apply weekly for 15 weeks. To calculate this, we would use the formula of total fertilizer in pounds over number of weeks. For our example, this would look like 318.44 pounds of CaNO3 over 15 weeks, meaning we would apply 21.2 pounds of CaNO3 per week to our area under production.
Let's say our farmer is growing similarly to the farmer in the last example, having 100 rows that are 100 feet long. They are now accounting for that 12-foot spacing of the row, meaning they are going to use more fertilizer than the farmer in our last example who used drip irrigation. To calculate this area, we're going to multiply 1,200 by 100 to get 120,000 square feet of area under production.
Remember that there are 43,560 square feet in 1 acre, and so we'll use the same formula we had earlier, the field area divided by that conversion, which will result in having 2.75 acres under production that will require fertilization. So now we have our area in acres, and we'll multiply that by our rate of 461.5 pounds of CaNO3 per acre, resulting in 1,269.13 pounds of CaNO3. That is our total fertilizer for our 60 pounds per acre rate for the total area under production. To summarize, always check the nutrient content of the fertilizer you are using and that it is right for your plant's needs. One of the best ways to determine what nutrients your plants need is to take leaf and soil samples to check their nutrient status. And finally, keep in mind how you're going to apply fertilizer when you calculate your fertilizer regimen. You can find other information on drip irrigation and fertigation through the UAEX website, fact sheets, and YouTube channel. We would like to thank those who helped us develop this video, and thank you for watching.